Hello everyone, welcome back again to the course Comprehensive Slope Stability Analysis using PLAXIS 2D. This is tutorial 23, Effect of Rising Groundwater Table on Slope Stability using PLAXIS 2D. So in this tutorial we are going to investigate the effect of rising groundwater on the factor of safety of slope using PLAXIS 2D. So in all previous previous tutorials, we assumed that the water table is located something below the top of the slope, and maybe in this situation the effect of water table is minor on slope stability in PLAXIS 2D. So as you can see in this figure, we have a groundwater table like this one. Actually, in reality, maybe the water table is not like this one exactly. Maybe it's in here at the crest of the slope. Maybe it becomes something like this one in a curved shape. But in PLAXIS, we will try to model this water table, which is 1 meter below the ground level at this location and at this location. So this rising of water table, maybe there are some reasons for this situation. One of them may be in case of heavy rainfall or snow melt. So infiltration increases groundwater table. So when we have a heavy rainfall or snow melt and this water infiltrates into the soil, so it causes the rising in water table in the soil. Or maybe in flooding or nearby river or lake rise. So when there's a flood or maybe rise in level of river or lake, and this is also increase the height of the water table in the soil, or maybe sometimes due to irrigation, leakage, or poor drainage in the slope, and also this causes excess water accumulation in the soil, and sometimes due to geological or land use changes and aquifers recharge or urbanization alters water flow, and this causes also the high in water table level. So I will open one of the lesson from previous. For example, I will open tutorial number 9, slope stability analysis using hardening soil model. And as you can see, in this example, we had the water table like this one, which is 3 meters below the ground level at here, and about 13 meters at top of the slope, below the top of the slope. So in as if I open the results in here, you can see the reach safety factor was about 1.6. So I will keep this water table, and I will try to create another or user defined water table at this location. So before doing that, I want to save this tutorial under a different name, which is tutorial number 23. I will paste the title in here and click on save. So right now this is a different or separate PLAXIS project. To do that, we can proceed to flow condition. So if I click on soil, and we defined this water table using a borehole. If I double click on this borehole, you can see the water table head is at 7 meters, and for other boreholes as well. So right now I will try to generate a user-defined water table. So we need to proceed to flow condition. This safety factor, which has normal water table, and click on edit phase. We can see in here the reach safety factor is 1.6, and if I click on safety factor when the water table rise, we can see the safety factor is about 1.19, which is approximately equal 1.2. So we can see how rising water table decreases the safety factor for the slope. And this is because when the water table rises, the effective shear strength of the soil is decreases. That's why the safety factor decreases. So we can also check the failure surface in both cases. And if I click on deformation, so we can see this is a failure surface in case of normal water table. And if I click on safety factor when the water table rises, we can see we have a deeper failure surface in this condition. We can also check the strain, as we can see, when the water table rise and when the water table is 3 meters below the ground level. So this lecture was about how rising the water table affect the safety factor in slope stability in PLAXIS 2D. I hope it was clear and useful. Thank you for watching. See you in the next tutorial.